One of the canards of our era is the environmental mentality that burning methane, which is natural gas, produces pollutants. Um, I don't do politics in this course because it has nothing to do with it, but that is flat out false. When you oxidize a substance or burn it, it produces products. And the products produced by methane, which you see above, and oxygen, produces carbon dioxide and water vapor. Leaves of all plants absorb carbon dioxide, use it as one of the constituents for making more leaves, for making parts of the plant. Um, Water vapor obviously is essential for life on the planet. We've talked about water extensively. Now, what you see above is an unbalanced equation. The reason it's unbalanced is you have wrong numbers on either side of the equation. You've got a carbon on each side, so that checks out pretty good, but 4 hydrogens on the left side and only 2 on the right. Now, as I schooled you previously, if you wish to balance by putting numbers in front, you can do that. So let's put a number in front of the water. And 2 works good. So now we've got 4 hydrogens on each side. Unfortunately for us, we've got 4 oxygens now because the 2 multiplies everything in the compound. So you got 2 with the water and 2 with the carbon dioxide. Well, just like it solves the situation on the right side, you can solve it on the left by putting a 2 in front. And we have ethane plus oxygen produces carbon dioxide and water vapor. Thus, in essence, a balanced equation because you have the same number on the reactant side. The reactant side is the side where everything is put together, and the product side is on the right side of the equation line. So reactants check out and products check out. So this is called the law of conservation of mass and energy. This is the mass part. You must have, by the definition of law of conservation, an accounting for everything that happens. In this case, you're accounting for the number of atoms on either side. Next thing I want to talk about is limiting reagent. Now, there's 2 very essential substances in our society, in our grouping right now. Okay, the top equation is nitrogen. I've already explained to you that nitrogen is the major component of the atmosphere. It's 78% of the atmosphere. So you have an unlimited amount of that in existence. Hydrogen, however, is 0.0005% of the atmosphere, thus is an inhibiting factor and produces a desire to obtain hydrogen whenever possible. Now, in the middle equation there, the N2 plus H2, that produces the number one fertilizer for commercial fertilizing. Without it, half of us will starve because we cannot produce an adequate amount of fertilizer using regular organic methods on the planet. It just doesn't happen. So ammonia is extraordinarily valuable. In the upper equation, we are limited by the least of the components. Since there is 78% of the atmosphere is nitrogen, so it's basically an unlimited supply. Hydrogen is called the limiting reagent in this reaction. And as you can see, it is not properly balanced. We always like to have things properly balanced. We have two nitrogens on the left side and only one on the right side, put two in front. Now we have two nitrogens on either side, but we got 6 hydrogens on the right side. Well, again, with our numbers in front, we can easily balance it, and thus we have nitrogen plus hydrogen producing ammonia, a very important substance for our living, surviving. Next, we have methane and water. Now, often everyone thinks that methane is only used to produce heat as a natural gas. But in the vapor state, if you heat methane vapor in an atmosphere of water, you can produce hydrogen gas and carbon monoxide gas, as I've not extremely well illustrated here. Let's clean this up a little bit so it's a little more visible. So hydrogen gas is desired because it's such a small quantity of the atmosphere. And again, in this instance, the limiting agent is going to be the amount of methane, since naturally occurring methane in the atmosphere is a fairly small quantity. So now you have methane plus water, and again, the atmosphere contains up to 2% water in certain areas, but overall we can say we have a fair amount of liquid water available. If you vaporize it and heat it with your methane, which is also heated, you have gases for all of these. So to indicate gases for these, we put a little G in parentheses below each of the components. And this produces hydrogen gas, which is light and thus is easily separated from the carbon monoxide, which is heavier. Carbon monoxide, of course, having a 12 for the carbon and 16 for the oxygen, giving you 28 versus H2, which is 2. There's a lightness of the hydrogen which allows it to be separated. Now, this produces the hydrogen we need for making, again, the methane or the ammonia for the fertilizer. So that's your illustration of limiting agents. The limiting agent in the top of these is that which is seldom found naturally in the atmosphere. Thus, it has to be piped into the reaction. Nitrogen, 78% of the atmosphere, we can always find nitrogen. And in the bottom one, you have Methane, again, is unlikely to find in the atmosphere because there is some natural methane produced as hydrogen, but still limiting. And water, which is in abundance in relation to the others. That is illustration of balancing equations, except we're still not balanced. I cannot forget that. On the left side, we have one carbon, right side, one carbon. On the left side, we have 6 hydrogens, and on the right side, we only have 2. Now, if we put a 3 in front of the hydrogen, we take care of that situation pretty quickly. Now we have 6 hydrogens on this side, 6 hydrogens on the left side, one carbon, one oxygen, and the reaction is said to be balanced. No chemical operation that you will do in this course is completed until you've balanced the equation. Now, all reactions do not normally have the little parenthesis behind them, only when they're a particular state of matter. If there is nothing behind it, this generally indicates that your solutions are water-based solutions. Thus the name water chemistry, which is often applied to the first semester or 2 of general chemistry. So you'll see a lot of reactions that will not have the gas. And you point out very righteously what's going on with the one above or the 2 above. They don't have the gas. So let's insert that in. We've got nitrogen gas. We've got hydrogen gas forming ammonia gas. Again, this can be compressed down and utilized. Over here, we've got methane gas burned in the presence of oxygen. Now, that burning can be shown with a triangle, which indicates heat and produces carbon dioxide gas and water vapor. Now, the water vapor obviously is definitely not a pollutant. Many of the folks are accusing the carbon dioxide as being a pollutant. That's just not defensible from a scientific perspective or even a rational perspective, since carbon dioxide is one of the major components of the construction of all plant life. See you next time.